Hello, my name is Aditya Bhargav and my teammates are Muskan and Nishan. Our CV project topic is object tracking using homography. The objective of this project is to address the challenges inherent in object tracking through the implementation of homography techniques. The problem lies in the need for a robust system capable of accurately tracking objects across frames in various real world scenarios, including changes in perspective, scale, and occlusion. The image of the object that is to be traced has been provided earlier and then traced using the system's camera. Further efforts has been made in the direction of estimating the pose of the object. For the later purpose, camera calibration of the system's camera has also been performed. We have divided our problem statement into three different sections. First, we have made a code for camera calibration, which is to be used for calculating the pose estimation. The second part of our problem statement is object tracking by homography. And the third part of our project is pose estimation by homography. The object tracking will track the object that is to be tracked, and pose estimation will give the rotation and translation matrices for that. The first part, that is the camera calibration, its methodology has been shown on this slide. The code first detects the corner of a chessboard pattern in input image and calibrate the camera based on these detections. This is the conventional method to find the camera calibration matrix. A chessboard image is used for the purpose because it has the corners that can be easily detected. Using the camera calibration parameter, it performs undistortion on example image to correct lens distortion. Undistorted images are safe to demonstrate the effectiveness of the calibration process. Reprojection error is calculated to evaluate the accuracy of the calibration. This process ensures accurate geometric measurements and enhances object tracking in computer vision application. The code and its debugging and its explanation has been shown later in the video. The results for the camera calibration has been shown on the screen. On the right image, camera matrix and distortion parameter has been shown. And on the left image, the corner that has been detected during the process is shown. Our next part of the code is object tracking by homography. Its methodology has been shown on the slide and it goes as follows. First, we will take the image that we need to track. It serves as a reference image for the task. Then we will convert it into grayscaling because we need one channel to do it. Second, we will do the feature detection and extraction. There are several methods that can be used to detect features and extract it. We are using Shift for this purpose in our project. Then we are doing camera initialization so that we can record the videos. First, we will pre-process the frame, that is, we are grayscaling the frame. Then we are feature detection in frame. This is the same as done above. We are using Shift for detecting the frame. Then we are matching the features. For this purpose, we are using the KNN method. Then we are doing the homography estimation, which has been done by the inbuilt function. And then we are doing projection transformation. At the final, we are displaying for each frame and then updating it. And then we will do for these frames again and again. The results for this has been shown on the slide. The circles that is shown on the left hand side image are the shift points that has been detected. These are matched then by the recording that has been shown in the middle. In the right, it has clearly traced the object. The third part of our image is pose estimation by the third part of the code is pose estimation by homography. We have further divided into two parts. First one is the processing. That is, how are we processing the video file that we are giving it to the function. First, we are reading the video file. Then we are blurring so that we can reduce the noise. Then we are using Kenny edge detector, which is a conventional function to detect the edges. Then we are applying the how transformation to detect most frequent edges. Then we are detecting the corner point using these edges, and then we are filtering and sorting for each frame, and then we are repeating this process for each frame. Then we are estimating the pose for the frames using homography. The earlier detected corner points are used to get the pose estimation. First, we are constructing linear system using known world coordinates of corner point and their corresponding image coordinates. Then we are performing SVD on resulting homography matrix to get rotation and translation matrices, storing for each frame, and then at the end of the processing for each frame, we are plotting the results. The results for every frame has been shown on the slide. These are graphs for rotation and translation. As we can clearly see, the translation is changing as well as the rotation part.